a catalog of essential functions, and here we'll be going over some simple things, um, mainly just functions that you'll see a lot in calculus, especially like sin x. You take the derivative, turn to cosine x. You take the derivative of cosine x, you get negative sin x, because that's a double derivative. But anyways, a mathematical model is something that uses real-world inputs to denote real-world estimated outputs. So an example of this would be Galileo, who found that the distance is proportional to time squared. So that means if you input time and square it, that's mathematical and you can get an output. So that's the logic behind a mathematical model, which is something that represents a real life situation and uses a mathematical model. There's other models as well. There's, I learned this in AP Environmental Science, but yeah, that's the logic behind that. Sorry, a polynomial. So this is really confusing, right? Probably because I put this power notation because I'm not sure how to do on here. So only the first leading function, so you can read it. Only the first leading function, so a in this case has to be defined. F of x equals 2x squared. It's a polynomial regardless of whether it has bx, which is the second term after. So I'm just going to write it down easier here. And your book will make it really complicated. It will be like n minus 1 plus a n minus 2 x n minus 2. Like, it's complicated. But all it means, and I'll write it as simply as I can, ax to the n plus bx to the n minus 1. All it means is that the leading polynomial will have the other polynomials decreasing as integer values. So something like 2x to the 0.5 is not a polynomial because this is a fraction and it's not an integer. So it has to be an integer. So n has to be an integer, and the leading polynomial has to be defined. It can't be 0. So, I mean, I guess 0 is defined, actually, but it can't be 0. So if it's like 0x cubed, it doesn't even exist, using some pretty simple logic. So, if we take this thing and we extrapolate it even further, it can go infinite, technically, depending on this. So this will be the leading polynomial, and that is called the degree. All that means is it's the highest integer power that exists within the polynomial. So let's take 4x cubed plus 8x squared plus 3. So notice how I said you don't need bx or cx. Like here, as you can see, I made a polynomial of 3 degrees, I guess. But here there's only 2 powers, and I didn't include this term right here. And this is a polynomial because it has an integer value defined, and the leading degree is 3. So that's all a polynomial is, which leads us to the definition of a rational function. And a rational function is just, the rational function is just, where a polynomial is on top, and we have and they'll use r of x because rational function, I guess. Let me just erase everything to use r of x notation, which just means that it's a function that uses a polynomial on the top and a polynomial on the bottom. Let's not use p again. Actually, we'll just use p2 to the x to denote this. So as we learned before, a polynomial is something with integer degrees like that, divided by x, which is, wait, is x a polynomial? Yeah, I'm sure it is by that definition. But we'll make it a little bit more complex. We'll just do x squared. Plus, actually, yeah, let's do x squared minus 4. Yeah, let me just think here. X squared, x plus 4. Okay, so we can rewrite this as x squared x plus 2, and we can rewrite this as x minus 2. X plus 2, you can cancel these out. But the thing about rational functions is that they will always have an asymptote on the bottom. An asymptote is something that makes the denominator 0. You cannot divide by 0. And I'm going to explain that logic right now. Let's say, dividing by 0 technically means that how many times can 4 fit into 0? Infinite. So you might think it's infinite. But then if you multiply 0 on both sides, 0 of infinity is 0, I guess, because you don't have an infinity. I'm not too sure about the axioms of logic behind that, but you can't divide by 0, and whatever makes it 0 is impossible, and is considered a vertical asymptote, which just means that it's an x value that yields a denominator of 0. So here we have two things that can yield a denominator of 0. And here I used algebraic manipulation to cancel out the top and bottom terms. But when you cancel out the top and bottom terms, they aren't really fully gone. And although this function will be the same as this function here, but what will actually happen is you'll have asymptotes here because this function evaluates PEMDAS first, so it evaluates each one and then does it. So that's the logic behind that. So x cannot be equal to or negative 2 even when you use algebraic manipulation. It's pretty simple, logical. PEMDAS, that's 5th grade stuff. Sine functions are 0 for multiples of pi. Cosine functions are 0 for multiples of n pi 2 divided by 2. This is simple logic just to get a... add a unit circle. I memorized it by myself without even looking at the unit circle because it's logic and common sense. So tan functions are 0 because every n pi, because technically it's sine over cosine. So you can rewrite tan theta as sine theta over cosine theta, and whatever makes the numerator 0 will make the whole function 0. So it has asymptotes, which would be whenever cosine is equal to 0 because you can't divide by 0. So logic behind such sine functions. Should be actually trig functions. I put sine functions. These are translations. F of x plus c means you translate function up c units because you're adding something to the output, which will just change the output up because the y-axis is the output line. Same thing for c. But here we have a little switcheroo, and it's the translate function down right c units if you subtract c. Interesting, right? And here we'll explain the logic behind that. And it's typically when it's parentheses also. So let's take y equals x squared, and then let's take y equals x minus 2 squared. So you might think you're subtracting 2, why wouldn't you move to the left? But the thing is, when we plug 0 in for both, we get 4. So 0 yields a value of 4. That's interesting, right? But you realize that for this to yield the same value as that, you need to add 2. So for it to be at the origin, just like the origin is 2 to the right because 2 makes it 0 and the origin is at 0. That's really complicated and wordy. I guess what I'm trying to say is that since you're subtracting 2 away from the input, you need a higher input to compensate for that 2 being taken away. That's the logic behind it. So, fogging off. You can read this now, but I'm just going to explain each one because I don't want to read that whole thing. So f plus g of x is the same thing as f of x plus g of x. So let's define f of x as x squared and g of x as 9x. So f plus g of x here would just be, guess what? You just add these functions, x squared plus 9x. And the domain is defined as basically the two things here. And I'm gonna get into what an intersection is. But all of these are the first three, which is adding functions, subtracting functions, and multiplying functions, all use intersection logic. So f minus g of x is the same thing. You just subtract each function. And then we'll have f times g of x, which will be written usually like this, which is the same thing as f of x times g of x. Now, what did I mean there? So, what's an intersection function? So let's take y equals x, square root x, and I guess I'll write f of x to be a little bit more professional. G of x equals x squared. Let me just do one thing real quick. Okay, there we go. So I guess the logic behind it is, let's say we add these functions. So what's the domain for this? And the domain is going to be infinite numbers because negative numbers, there's nothing that makes it undefined. So all real numbers. And we say real because, I guess imaginary ones would still be defined because when you square them, it becomes negative 1. But all real numbers is the domain here, and all real numbers here, or the only numbers defined is x greater than 0 because you can't take negative roots. X greater or equal to 0. So when you do f plus g of x, you might wonder, what's the domain of this? All it is the intersection, which basically means the minimum, the highest minimum, and the lowest maximum. Wait, let me think if I worded that right. Yes, the minimum that's the highest and the maximum that's the lowest. So the maximum here that's the lowest is nothing. They're all defined past 0. They don't have a maximum. But the minimum is anything below 0. So that's the domain of that, and it would be to infinity or x greater than 0. Logic, pretty simple, easy. Now we're going to get into composition of functions, which are quite complicated because we evaluate them in PEMDAS again. So all this means is we define this function first, and we get it in there. So that's a little complicated. So let's take g of x equals x squared, and let's take f of x equals square root x. Very simple functions. Now, what is f of g of x? This is the same thing as f of x squared, which all that means is you put x squared in here. That's literally what this means. G of x is becoming the input. Now, what people will do is they'll simplify the function. X squared square root. So what's the domain here? So what people will do is they'll cancel this function out. So they'll just say x, which in this case it kind of works because x squared is always defined and square root. But you can't just simply cancel them out. And I guess we'll use the other way around, which is g of f of x, which is just the same exact thing except the two functions reversed, which is square root x times squared. So you might think, oh, you can just cancel this out. You can't, because the calculator, or just functions in general, the logic of functions, it goes PEMDAS, so it evaluates what's in the parentheses first, and you can't evaluate a negative number, so the domain here would be all real numbers. So the logic behind the domain is that it is defined for all real numbers within the first function, which is the input, which is g of x here. So if the domain has to match the domain of the inputs and the domain of the output, which is f of g of x, and then you find the cross term, or you find the intersection there, which we explained earlier, is just the highest minimum and the lowest maximum. Logic, calculus, kind of easy, but it will get harder, especially next one where I explain epsilon and sigma. I mean, not sigma. Forgot the other Greek letter, but yeah.